Okay, so hello everyone. So we were presenting, so I'm Laurent Grangeau and I'm working in a big French bank company as a DevOps coach, and I'm working with Christophe.
Hello everyone, I'm Christophe Lecointe. So I also work in a big French bank with Laurent. I'm more on the tooling part of the team, which means that I provide the tooling for continuous delivery to all the teams in the bank.
Okay, so now a little overview of software in bank industries. So for those who aren't familiar with the banking industry, this industry is heavily regulated by rules driven by central banks. So if we have an overview of the banking industry, so we have no agile process, mainly waterfall processes, ETL compliance. All the releases are manual, so with people. Nothing is automated, and we have lots of service interruptions, so it's not good for banking industry, because when we have 1 second of service interruption, it may be thousands of millions of dollars of loss. So, as I said, the banks are heavily regulated. No, banks can do what they want. There's lots of regulation and auditing, mainly from the BCE in Europe and Fed in America. We are working with a very old legacy code. Mainly, generally, the base code is superior to 5 years old. We are working also with obsolete infrastructure. We are mainly speaking about mainframes, COBOL programs, specialized appliances with Spark architectures. So it's really difficult to have community hardware and to automate things with API like all of you guys do. We're working with monolithic software because they were designed years ago. There was no microservices, no 12-factor, no automation, no everything. So this is an overview of the banking industry right now. But now banks are facing new financial startups like the fintechs. So what is a fintech? A fintech is a technological industry that leverages on cutting-edge technology to be more agile, faster, and to deliver more business value to the end user. So the banks are facing with fintech. And here is an overview of the landscape of fintech. So you probably know PayPal, Square, it's all fintech. It's about 12.7 billion of funding. It's over 1,000 companies, and they're growing rapidly. A new technology arrived at 2008 called the blockchain. So everyone knows blockchain. Everyone knows Bitcoin because it's mainly used in China because we have a crisis in China, so Bitcoin is here. At the moment, it's nearly 1 billion cumulative investments with blockchain ecosystem. We're talking version 2 of the blockchain, which is called Ethereum, if you know. There's about 800 blockchain startups and about nearly 5 billion Bitcoin capitalization. So here is what the banks deal with. So, like I said, the fintechs are coming like a tsunami over the banks. So it's a little Japanese estamp. And fintechs are taking market shares, so it's time to react. Fintechs, like I said, it's very agile, very fast, and deploy new feature very rapidly. So the bank we are working in, launched a program called the Continuous Delivery Program. In 2013, so 3 years ago, there was a big program which I will explain later. And the main goal was to be like the GAFA. So we are transforming a bank, a very old bank, we are talking about 150 years old, to be more like a GAFA. GAFA, it's Google, Amazon, Facebook, and Apple. The main goal is to be faster, to bring more business value, and to reduce maintenance costs. So, what consists the program? The program consists of several parts. So we have, first, as a DevOps coach, I have to work with people with an old mindset. So I have to change the mindset of people. So to explain what is DevOps to the people, what is DevOps to ops people who used to SSH on production server, to use DB like everyone else. We have to talk with people which processes are waterfall, so we have to explain what is agile. And we have to work with developers which aren't very familiar with TDD or BDD. So we'll explain that later. The second part is to implement tools to allow continuous delivery at scale. So we're talking about 2,000 applications in the bank, over 5,000 nodes of infrastructure. And the last part is to work on a framework to improve reusability of libraries or so on. So the main part is the change management. Agile, we have 3 types of coaches. The agile coach, which their jobs is to bring more business value and to involve more stakeholders. So we are working with them to implement Scrum or Kanban, even backlog grooming, to have more demo, more retrospective. So we have to be faster and to deliver more rapidly. But you don't deliver software like this. You have to test your software. You have to have clean code. So this is the second part. We have software craftsmanship coaches, which their main job is to build robust, testable, and sustainable code. So we use patterns like TDD, BDD, clean code, clean architecture, pair programming, extreme programming, etc. So all the buzzwords you know in software. And the last part is, like me, a DevOps coach. So it's to automate the delivery using infrastructure as code, automated deployments, pipeline, continuous delivery, etc., etc. So I'm going to let Christophe talk to you about the platform we have set up.
Yeah, so I'm going to present to you the platform we set up, because once you have the good practice, you need the good tooling that goes with it. So the first tool of our pipeline, of our continuous delivery pipeline, is Jira. So the backlog grooming tool. It's used by developers to bring into life the agile practice they practice thanks to the coaches. So on Jira, they can put their tickets, they can prioritize the features they want to develop, they can ask for feedback from customers. Once you know what you want to develop thanks to Jira and the agile practices, you want to actually code everything. So we also provide the IDE for the teams. So Visual Studio, IntelliJ, Eclipse, whatever they want, we provide them pre-configured. Once you have coded all the features you need to store them into a source version management. So we used to use a very old way of doing things like SVN, very private repo on SVN and everything. And what we implemented is actually an on-premise GitHub, because we want to favorize collaboration between teams. So we want everyone to actually share their code and put into place some kind of internal open source. So now everyone is pushing their code on GitHub. The repositories are public by default. So everyone is actually sharing their code with everyone unless they have a reason not to, which is a really big change of mindset. Once you have all your source code that is versioned, that is shared on GitHub, you can use a continuous integration server to build everything, because we don't want that something that have been built like on the laptop of a developer somewhere with God knows what ends up in production. So the only part that goes in production are the parts that are the artifacts that come out of the continuous integration server. So for this, we provide Jenkins and TeamCity. Jenkins, well, with the continuous integration, we want automated tests. So what we are doing is that we're providing all the tools to do code coverage, to do testing, and to provide code quality reports. So for example, with SonarQube, with JUnit, and also all the tools that are used for BDD like Cucumber. Once everything is built, you need to store the artifacts somewhere, the artifacts that have been built. So for this, we use, as a library repository, we use Nexus. On Nexus, we also store all the dependencies where everything is built. Actually, nothing is taken straight from the internet. Everything is taken from Nexus because we want to have really control about what is taken inside the bank. And we also want to be able to audit what is used. So everything goes through Nexus, and even things that are taken from outside are actually proxified via Nexus, so we can monitor everything. And once you have been able to build everything and to build everything, everything is completely versioned. Everything has been automatically tested. It has been built by a CI server. We can automatically deploy it. So by using XLDeploy, it's a tool provided by Xebia Labs that completely automates the deployment. So we simply generate one artifact that we upload on XLDeploy. And it's going to use this artifact to automate the deployment from development to staging to even production. So now we have a lot of teams that are using this to deploy straight into production. And once you have everything, once you have all the pipeline, what you probably want to do is to have a completely flexible way of deploying and flexible infrastructure. So we implemented, as Laurent said, infrastructure as code, which means that there is a private cloud inside the bank. And we can request, for example, to spawn a development environment. So the developer push on GitHub. The CI server builds everything. Once everything is built, it runs all the tests. If everything is green, it asks to spawn a development environment, and it automatically deploy the thing you just built on this deployment environment. So for this, we use the private cloud, and we also use Puppet to set up everything. And we also use Puppet to set up the infrastructure in XLDeploy. So what happens with this tooling? So this is everything that we are currently using, that we have set up during the last 3 years, and that is working as a charm. So we have more than 400 applications that have been transformed, that are now using our continuous delivery pipeline. We have reduced the deployment times of application from sometimes months to just a minute, because everything is done automatically. You just have to do a push, and everything is automatically built. Everything is automatically deployed to development, and then you can upgrade very easily. And the time to market for new features has been reduced from months, when you have to check everything, when you have to go through QA and everything, to a very short time, like 2 weeks, pretty much an agile sprint, the duration of a sprint, to have a new feature and eventually in production. So now that we have set up everything, what's next? Because once we have set up everything, we started to face a whole lot of new challenges that we couldn't see at first. And so we are now working on the next step of our platform to bring new features and to automate even more. So let Laurent keep going.
Okay, so the new challenges we are facing is variabilization. Sometimes applications have lots of variables in Java properties or even .NET properties. So they must be externalized. The new challenges also service discovery. So we are moving from a static world, static infrastructure, where we know all the servers, all the IP address, and everything, to a new world that all is mutualized and all is dynamically generated. So we can't figure out the IP address or the port address and things like that. We are facing issue with infrastructure hybridation. So I'm talking about private and public cloud. So now we are also have a proof of concept with public cloud like AWS, GCE, or even Azure. So we want to have an hybridation between public and private cloud. As we have public and private cloud and heavily mutualized infrastructure, we have to deal with multi-tenancy. So an application don't have to see what another application do, and stuff like that. And we're also facing with secret management, where we store secret to connect to private or public infrastructure, where we store secret from production, development server, etc., etc. The new applications are developed now in Greenfield with microservices in mind, so topology who moves, and 12th factor. They have to be resilient, secure, like I said, elastic, and they don't have to be aware on what hosts they are running on. So to achieve that, let's use HashiCorp tools like Vault or Consul. So now we will talk about use cases and how we evolve our platform from the old one and from the new one, because we are leveraging also on Docker, heavily on Docker. So
basically, the new platform that we're trying to set up right now, it's really a work in progress. Nothing is set in stone, but that's what we're currently working on, and it's working quite well so far. As Laurent said, we're trying to go a lot toward Docker because Docker simplifies a lot of use cases. It allows us to deploy the exact same artifact from development to production, and on pretty much the same environment. So as I said, we're trying to use, for deployment automation, Docker and UCP. For library repositories, we're still going to use either Nexus or Artifactory, because you still have to return your artifact somewhere. But we're also going to use Docker Trusted Registry. That's what the little oyster is. And once that is done, we are going to deploy that on on a big Docker swarm, which is basically a cluster of Docker engine. And for that, we are going to also use HashiCorp tools such as Consul for service discovery and variabilization, and Vault for secret management. And this allows us to manage a new architecture for applications such as microservices in a much easier way and much faster way.
Okay, so now I'm presenting 5 different use cases we have implemented in the big French bank with Consul, and then Christophe will talk about 3 use cases we have implemented with Vault. Okay, so the first use cases is, like we said, we have a large swarm cluster with lots of Docker engine. And on each of the Docker engine, we have a Consul that listens to all the started container and stopped container, and they feed the registry, so they feed Consul. So at any moment, we know what container runs on any host, and if a host is up or down, the containers will move accordingly to the living host. So it's the first use case we are currently implementing. We have currently implemented with Docker Swarm. So, like I said, okay, so you don't have the 3 different environments. So the first on the left is development environment. The middle one is staging, and the right one is production server. So we are dealing with applications that sometimes have more than 800 environment variables to externalize and to store somewhere. So we are using console as a KV store. Sorry. The console is a high availability cluster, so it's managed by the infrastructure team, and the infrastructure team brings us a cluster when we need to. Imagine an application, a topology of application, which is running two containers. So here the two containers on the development side, and as the container starts, we have to get the information where is a DB, where is I don't know the properties of the Java file. So we will talk with KV Store directly with the API of the library, the API of the library or the library, the Java library. So once we see that the development environment is working, we're deploying the same topology, the same containers on the staging environment, and we're getting pretty much the same variables in the KV store, which a minor difference between development and staging because we don't have the same password, the same login, the same URL, etc. Once we see that the staging environment is working, we update the new version in the production cluster of the KV store, and then we deploy the topology of the container in production. And the containers will get the information from the registry. So we see that we have completely separated running code of configuration environment variables, and so the container is completely agnostic from the environment. So it's the same container we use from dev to production as the environment variable is externalized and not in GitHub or Git or SVN and not in the container itself. So it's the second use case where we use console. The third one, so it's service discovery. So imagine we have a service provider. It's running on a cluster swarm. We don't know where it's running, and we have a service consumer that want to consume the providing services, and we want to know where is the service. So when the container of the service provider starts, it's publish itself to the registry, and then the service consumer can find where the service is running, and then get its IP or port and bind to the service provider easily. So it's one of the use cases. Like I say, it's a dynamic environment, so maybe sometimes we talk about microservices, so we can scale up or down the microservices, the Python container in this example, and it automatically publish the new containers on the registry, and the service consumer can then get the information, and the registry can act like a load balancer between microservices. So it's a really, really useful use of console because it's dynamically generated, and we don't have to know where the different services are. So the fourth one is in the network overlay. So what we're talking about the network overlay. So like I said, the cluster swarm is heavily mutualized. So we want multi-tenancy, and we only want the containers to speak with themselves. As you see on the first layer, imagine the two containers are microservices. The first one is a Python service, and the second one is a MongoDB services. You see that the first container exposes publicly an interface, IP and port, to the container on the second layer of SDN, and only by this public access point, the container can speak to themselves. So you have multi-tenancy because, for example, the container on the bottom third layer cannot see the containers on the top layer, even they're on the same host. So they really can't speak together because we have separated with the networking, with SDN, the two containers. And the last use case we used, as I said, we have a private cloud with assets and capabilities. And imagine you spawn a container on the private cloud, and then a second one, and then two more, and then two more, and the private cloud is very full. So we don't have any assets which can support more containers. So what we do is to spawn container on the public cloud. Imagine it's AWS and with a VPC link between them. If we can spawn, we can overflow the running containers on the public cloud. And with the help of Consul, we have a bus of exchange. And the end user, the running containers, don't know where they're running on. They're running on private or public clouds. For them, it's all the same. So it's very, very useful use case because you can be elastic and you don't have any service interruption as we spawn more containers on the public cloud.
So now I'm going to talk to you about all the use case we found for Vault. So Vault can be used as for secret management. So the very first use case we saw that's going to be very useful for us is the password generation use case. So for example, in this case, we have an application, a very simple Python application that's going to communicate with a Postgre database. So what we want, what is currently happening is that to communicate with the Postgre database, we actually have to provide the credential directly to connect to this database. And if we want to scale this, we're going to have, like for example, 3 instances of this application. We all are going to use the same credential to hit the database. So that's not really great because what we want is to have clear separation. We want to be able to exclude one instance, for example, if for some reason the credential gets leaked or something like that. So what we can use Vault for is to automatically generate the credential. So what we're going to do is our instance of our application is going to ask credential to Vault. And Vault is going to actually generate a brand new pair of credentials that it's going to send back to our application. And then the application is going to use those specific credentials to connect to the Postgre database. So that's really great because once you have that, you can scale as you want because each one of these instances is going to have its own pair of credentials. It's going to have its own user password. So what happens is that you can have a very specific auditing for the Postgre database. You can know which instance accessed the database, which did what, very precisely. And if for some reason one instance get hacked or whatever, or you need to revoke the access, you can revoke the access on only one instance without any issue. You simply have to ask Vault to revoke the access on this token, and everything that this instance was connected to is going to get revoked. So it's great because in this case, we have only one database, but we can have access to several things. We can have access to 3 or 4 databases or other services. And so we can really revoke access to everything that this specific instance has access to without touching any of the other instances. And we don't need to give the same hard-coded credential to everyone. The next use case that we found that's going to be very useful is that, for example, you have an application that's running in production, and for some reason there are bugs, and you need to go troubleshooting. There's a very big trouble, and you need to go to log into the production server to troubleshoot. Except that the guys from operation don't want to give you the user password for the production server because, well, they don't want to give you that because it's a very sensitive information. So what they can do is that you can request credential via Vault. which is going to generate credentials specifically for you. For example, one-time credentials that are going to be very short-lived. They can give you access, for example, for 1 hour on the production server. And then, with those credentials, you can log in, and you can log in with credentials that are going to be valid specifically only for troubleshooting, which means that they're going to expire very soon, and they can define exactly what they want to give you as rights, because you can define, okay, this guy is going to have read access on this, this user is going to have write access on this. The operation guys can really give you a specific set of rights for a very specific time. So this is going to be very, very useful. And it works for pretty much for SSH and database, which are our main use case. And the third use case we saw that we will use is automatic certificate generation. So to come back to what Laurent presented earlier, if we want to use network overlay, and we want our containers to communicate with each other, we actually don't want them to communicate in plain text. Obviously, we want them to use SSL and everything. But the problem is that we cannot provide the certificate at build time, because if we do that, everyone has the same certificate, and it's really not great. So what we want is to generate the certificate at the moment we spawn the container. So that way, we spawn a new container. It's going to ask to vault a certificate, and Vault is going to give it a very specific certificate that can be later revoked and everything. And so each container will have its own certificate. We will make sure that it can be short-lived, to be renewed regularly, and so on. So this allows us to have a very easy way and a very safe way to generate certificate, and mostly to do it on demand, and not have to open a case for someone somewhere to open it, because what we want is really automate everything as much as possible. So now we were supposed to have a demo right now, but there was some issue on our side. So it's not going to be a demo, but I was actually going to present you a bit about the continuous delivery pipeline that we're currently working on. So basically, on the demo, what we would have had is an application, a very simple application, a Twitter-like that was communicating with a Postgre database. And actually, there was no credential in the Python application. It was just requesting Vault to generate the credential for the connection. And the interesting part was that we had the whole pipeline of continuous delivery behind that, which means that we simply had the developer that commits something onto GitLab, so it's pretty much like GitHub. GitLab automatically warned Jenkins that there was a push that have been done on the repository. So what Jenkins did was to deploy automatically everything, pull the repository and deploy everything that was pushed, and deploy it automatically on a swarm, so on a Docker swarm. And this would allow us to very easily actually update our application, because if there is a modification, automatically the commit is done, the deployment is triggered, and everything is deployed, but only what have been modified. And of course, this was a very simple thing, but we can, from this base, we can add a lot of things. Like, for example, Jenkins, instead of deploying straight, is going to do the test, and only if the tests are green, we're going to deploy. And there are a lot of things that can be added, but it was the base of the demo.
Okay, so now it's our conclusion. Our conclusion, we have a 3-year journey through continuous delivery to bring continuous delivery to an old legacy company that is the banking industry, and we have success in our journey, because now the continuous delivery is part of the bank. It's a normal process for greenfield development, even as brownfield development, so legacy code. And I'm currently working with an old application that is 20 years old. So imagine lots of TIBCO, VisiBroker, Corba, and stuff like that. So it's I'm migrating it to Docker. It's a very huge change of the manner of working because we are talking about continuous delivery, continuous deployment, agile, and everything like that. And nearly everything is now automated, so it can be triggered by CI like Jenkins, or via CLI, or via API, or whatever. So it's really huge success in this bank. That's
So
all.
that's it for our presentation.